Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Mind Maps, we'll be dealing with the chapter Carbon and its Compounds. This is the fourth chapter in the science syllabus for grade 10 students of CBSE. So in this chapter, we're going to be looking at the basics of organic chemistry. So we're looking at carbon as an element and what makes it form so many compounds. Then we are going to be looking at various other topics here. So carbon and its compounds, we'll be looking at properties of carbon, types of organic compounds, and then functional groups, and finally some reactions. So first of all, carbon. Now, carbon only occupies a small part of the Earth's crust, but it's one of the most important elements with respect to life. So, in our daily life, we come across many materials which are made out of compounds, and most of these compounds are ionic or covalent. And a greater percentage of covalent compounds are actually made of carbon. An example for a carbon-made compound is your food. And another example would be plastics that you use, and then the fuel that you burn. So all of these are organic compounds. So definition of organic being, it contains carbon, and other than carbon dioxide, carbon monoxide, and carbon itself, the organic compounds entirely are composed of carbon and then other functional groups. So carbon has some unique properties which makes it the perfect candidate for forming compounds which are vital to life. So in this chapter, we'll be looking at properties of carbon, the types of organic compounds, especially acyclic, cyclic, unsaturated, and saturated compounds. Then we'll be looking at functional groups in carbon compounds, and then finally some reactions which are related to carbon compounds. So the first topic is related to properties of carbon. So what makes carbon form so many compounds? Now, carbon is just like any other element in the periodic table, but it has more compounds than any other element combined. So carbon has compounds ranging up to the millions, and there are some unique properties which make carbon the perfect candidate for such compounds. Now, carbon has the atomic number 6, so therefore that means carbon has 6 electrons in an atom. And so you will have 2 electrons in the K shell and then 4 electrons in the L shell. Now, the L shell is the final shell, so in order to complete its octet, carbon needs 4 electrons. So that makes carbon tetravalent. So its valency is equal to 4. But the problem with having a valency 4 is you cannot form C4 plus or C4 minus. Both of these are not possible. C4 plus we cannot form C4 plus because it would require a huge amount of ionization energy. If you don't know what ionization energy is, it's basically the energy required to remove an electron. So ionization energy is high in order to maintain C4 plus. And if you're looking at C4 minus is unstable because you will have 6 protons struggling to hold 10 electrons in a stable octet. So therefore, both C4 plus and C4 minus are not possible. So what carbon does is it shares its electrons. So when carbon shares its electrons, it forms covalent bonds. So covalent bonds are bonds which are formed by sharing of electrons. So the valence electrons are present in the outer shell of both atoms, and that constitutes a bond, a covalent bond. Now, sharing of electrons or covalent bond is found in many elements, especially halogens and then chalcogens such as oxygen, etc. But carbon especially has a huge amount of compounds it has compounds ranging to the millions. So other than tetravalency, what makes carbon so good at forming millions of compounds? Carbon has this unique property known as catenation. So what exactly is catenation? Catenation is the ability of carbon to bond covalently with other carbon atoms. So you can form a huge chain of carbon atoms using catenation, and you can form a very large compound containing many carbon atoms because of this unique property. And this is due to the fact that carbon has a small size. So carbon is extremely good at catenation. There is no other element which does catenation to the extent of carbon. Another example of a material which does catenation is silicon. Silicon can form up to compounds which are 7 to 8 units long, but carbon can form a compound that can stretch to the millions. So therefore, carbon is extremely good at catenation because of its small size and tetravalency. And also, carbon as itself has appreciably high electronegativity because of its small size. So because it only has till L shells, so therefore the size of carbon is not very conspicuous. So therefore what happens is that because of electronegativity, it forms strong bonds with other atoms which are also stable. Another unique property about carbon is isomerism. So isomerism basically means you can form different structures for the same chemical formula. So with carbon, you can do that. So if you have a carbon compound, say having 4 carbons in it, you can either put the 4 carbons in a straight chain like this, or you can form something like this. So these basically have the same formula if you write it down chemically, but if you look at it in a structural point of view, they are different. So this is what is called as isomerism. There are various types of isomerism. You have structural isomerism, stereoisomerism, functional group isomerism, etc. Now, isomerism is a topic that is discussed when you reach grade 11 and you start studying organic chemistry in deep. Right now, you just need to know that isomerism is when, for the same chemical formula, you form different structures. Carbon is also extremely good at forming allotropes, which are basically carbon forms, pure carbon forms in with different properties. An example of that is diamond, which is the hardest mineral in the world. Another example is graphite, which is the only nonmetal to conduct electricity. So these all are allotropes of carbon. Now, from the unique properties of carbon, let's look at the types of organic compounds that carbon forms. So organic compounds, as we mentioned, are compounds which are formed with carbon. And when we're talking about organic compounds, we usually first divide them into acyclic compounds and cyclic compounds. So acyclic compounds are the compounds which either have a straight chain or they have a branched chain. Now, the unique thing about acyclic compounds is that they're not closing together, they're not forming a closed structure. The structure is open, and that's why it's called acyclic. Now, acyclic compounds are further forming unsaturated hydrocarbons as well as saturated hydrocarbons. So in this section, we're looking at saturated hydrocarbons in particular. So what exactly is a saturated hydrocarbon? A saturated hydrocarbon is a hydrocarbon in which the valencies of all atoms of carbon are satisfied with the use of single bonds. So suppose you have a carbon atom, and since it's a hydrocarbon, we will have hydrogen only. A hydrocarbon is basically a compound with only carbon and hydrogen. So in order to fulfill the tetravalency of carbon, you need to have at least 4 hydrogen bonded to this carbon. This forms CH4, that is methane. So methane is an example of a saturated hydrocarbon, a hydrocarbon which fulfills its valency with the use of single bond with other atoms, or even with carbon atoms. So saturated hydrocarbons are commonly called as alkanes when they are acyclic. So alkanes have the chemical formula CnH2n plus 2. So that means if you have one carbon, the amount of hydrogen that encircles it is 4. The amount of hydrogen that bonds with it is 4. That gives you the formula for methane. If you look at the homologous series, ethane is the alkane which has 2 carbons. It is C2H6, again using the formula. Propane is C3H8. Butane is C4H10. Pentane is C5H12. Hexane is C6H14. Heptane is C7H16. Octane is C8H18. Nonane is C9H20. And decane is C10H22. So this is a small portion of the homologous series of alkanes. You can add more carbon atoms to form more alkanes. So alkanes, the important thing to note is that they're saturated, which means only single bonds are present between any atom. So that is the basic idea when it comes to saturated compounds. Another property of saturated compounds is that they are not very reactive. If you try to use chemical reactions on them, then they are pretty sluggish, pretty slow, because their bonds are already saturated. So they achieve sp3 hybridization. So therefore there is very less reactivity associated with these compounds. Now, what are the types of reactions that come under saturated hydrocarbons? So saturated hydrocarbons undergo one of 3 reactions. The first reaction is called as combustion. Combustion is a fancy term which is used for burning in the presence of oxygen. So combustion is the reaction in which carbon burns in oxygen to form carbon dioxide. So the product generally is carbon dioxide. Additional products are heat and light. So combustion is a reaction that occurs in all carbon compounds, whether they're saturated or unsaturated. So combustion occurs everywhere, and it is essentially burning in the presence of oxygen to form carbon dioxide. Now, an example reaction for combustion is the combustion of methane. Methane plus O2 gives you CO2 plus H2O plus heat and light. So methane is actually a fuel that we can use. The methane is actually present in natural gas, so it's used as fuel. So this reaction is pretty important commercially and also scientifically. The second reaction associated with saturated compounds is oxidation reaction. So oxidation reactions are reactions where you have a loss of electrons, a gain of oxygen atoms, loss of hydrogen atoms, etc. So these kinds of reactions are known as oxidation. They occur in carbon. An example for that is the conversion of alcohols to carboxylic acids. Now these are functional groups. We'll discuss them later in this video. And if you look at an example reaction, that is C2H5OH plus it in the presence of alkaline KMNO4 and acidified K2Cr2O7 forms ethanoic acid, acetic acid, vinegar, that is CH3COOH. So this is an example reaction for an oxidation. Oxidation occurs in the presence of oxidizing agents that get reduced in order to form an oxidized compound with that carbon with the hydrocarbon or carbon compound. So combustion and oxidation are two of the three reactions. The third one is substitution. Substitution occurs in only saturated compounds, and basically in substitution what you essentially do is you see that the carbon compounds undergo replacement of H with other atoms. So for example, if you have methane and if you treat it with chlorine in the presence of sunlight, what you see is that you get CH3Cl, that is chloromethane, plus HCl. So one hydrogen is taken out, one chlorine goes in. And if you were to do this with CH3Cl, you will get CH2Cl2, and then you get CHCl3, that's chloroform, and finally you get carbon tetrachloride, that is CCl4. So in substitution, the hydrogen gets replaced with other atoms, most notably halogens such as bromine and chlorine. And it happens mostly with saturated compounds. Unsaturated compounds do not usually undergo substitution. But that's all with respect to saturated hydrocarbons. We learned the homologous series, the general formula, why are they known as saturated, and the types of reactions they undergo. Now, saturated compounds are only one part of acyclic compounds. The other half is unsaturated hydrocarbons. Now, what are unsaturated hydrocarbons? Unsaturated hydrocarbons are hydrocarbons where the valency of at least one atom of carbon is satisfied with a double bond or a triple bond. So this is the basic definition for an unsaturated hydrocarbon. A hydrocarbon where the valency of at least one atom is satisfied with double bonds or triple bonds. And that's why they're known as unsaturated. Now, since you can use double bond or triple bond, you will have two types of unsaturated hydrocarbons. Alkenes, which are unsaturated hydrocarbons, they have double bonds present in them, and their general formula is CnH2n. So that means for ethene, it will be C2H4. For propene, it's C3H6, and so on. So that gives you the homologous series of alkenes, this general formula. And then when you're using a triple bond to form an unsaturated hydrocarbon, you form alkynes. So alkynes have the general formula CnH2n-2. So if you look at the homologous series of alkynes, you get ethyne as C2H2, propyne as C3H4, and so on. So those are the homologous series for both alkenes and alkynes. So remember, alkenes have a double bond, alkynes have a triple bond. Now, when it comes to types of reactions in unsaturated compounds, combustion and oxidation were discussed in the section for alkanes. So combustion and oxidation are also occurring in both alkenes and alkynes. So these two reactions, that is combustion and oxidation, they occur in all kinds of carbon compounds. The reaction that is unique to unsaturated hydrocarbons is addition. So what is addition? In addition, unsaturated hydrocarbons add hydrogen in presence of a catalyst such as palladium or nickel, and they add hydrogen in order to form saturated compounds. So it's basically the conversion of an unsaturated hydrocarbon into a saturated hydrocarbon with the presence of a catalyst such as nickel or palladium. So if you look at a general reaction for this, so you have, we'll take an example of a general alkene here. So R2C double bond with R2C, it in the presence of nickel and hydrogen, gives you C2R4H2. So this left hand side is unsaturated, the right hand side is saturated. An important example for an addition reaction is when you take vegetable oil and it undergoes hydrogenation to form vegetable ghee, that is vanaspati. So formation of vegetable ghee from vegetable oil is a product of the addition reaction, so it undergoes addition reaction to form vegetable ghee, which is an important part of our kitchens. So that's all about unsaturated hydrocarbons. You learned about the two types of unsaturated hydrocarbons based on which bond is used to satisfy the valency. You looked at their general formula and the homologous series, or at least a part of that. And then we looked at the types of reactions where addition is the most important when it comes to unsaturated hydrocarbons. Combustion and oxidation were already discussed in the previous section. Now, saturated compounds and unsaturated compounds are both acyclic, which means that they have an open chain of carbon of the compound. The compound, it has an open chain. It's not closed. But what happens if your compound gets closed? Then it is called a cyclic compound. So a cyclic compound is a compound which has a closed chain. So it forms a ring-like structure. Cyclic compounds can have two types. So if you look at cyclic compounds, they can be written as alicyclic and aromatic compounds. So what is the difference between the two? Well, if you look at our acyclic compounds section, we remember that saturated compounds had all single bonds, which had all their valencies, satisfied by single bonds, and in unsaturated hydrocarbons, either a double bond or a triple bond is used to satisfy at least one valency. So it's a similar difference here. So in allocyclic compounds, an example for an allocyclic compound is C6H12, which is cyclohexane. So in cyclohexane, we have 6 carbon atoms, which all undergo single bonding. So there's one type of bond that is bonding all the 6 carbon atoms. So this makes it an allocyclic compound. The other type of compound, which is an aromatic compound, is a compound with 2 different types of alternating bonds. So if you look at an aromatic compound like, for example, benzene, so this is the structure for benzene. So as you can see, you have a single bond between 2 carbons, then a double bond, then a single bond, then a double bond, and then a single bond, and finally a double bond. So this is the structure for benzene, and as you can see, there are 2 different types of bonds present in the closed compound, and that's why it's called an aromatic compound. So benzene is an example for an aromatic compound, and cyclohexane is an example for an allocyclic compound. Both have closed chains of carbon atoms, and that's why they're called cyclic compounds. So those are the 2 main types of organic compounds. You have cyclic, which contains allocyclic and aromatic. Then you have open compounds, which contain saturated alkanes, unsaturated alkenes, and alkynes. So that concludes types of organic compounds. Now, so far we have discussed only about hydrocarbons, which are carbon compounds which contain only carbon and hydrogen. But all compounds of carbon are not necessarily hydrocarbons. Carbon is also friendly with a whole range of other atoms such as oxygen, halogens, etc. So how do you recognize if carbon has bonded with something other than hydrogen? You will see that their structures contain functional groups. So we're going to be looking at functional groups next. So what essentially is a functional group? A functional group is a specific grouping of atoms with carbon which give specific characteristic properties to the carbon compound. So when you bond carbon with something other than hydrogen, then it usually forms a functional group, and in this functional group there will be specific properties related to that functional group which is applicable to the entire compound. So functional groups are pretty important because they make sure that you form different classes of compounds. Now there are many different kinds of functional groups. You have haloalkanes, halo compounds. So in halo compounds you will have a halogen as the functional group, and an example for that is chloromethane, CH3Cl. Next you have alcohols. In alcohols you have an OH group as the functional group, and an example for that is methanol, which is CH3OH. Now another compound is a carbonyl compound. So in carbonyl compounds you basically have a double bond with the oxygen and then a hydrogen added to it. So double bond with oxygen, if a carbon has double bonded with oxygen, then it's called a carbonyl group. There are two carbonyl groups. You have aldehydes and ketones. In aldehydes there is a carbon double bond, and then to satisfy the carbon's valency you have hydrogen at the end. So aldehydes usually occur, so aldehydic functional groups usually occur at the end. An example for that is methanal, which is which is ethanal. So in ethanal you have CH3 C double bond O H. So this is ethanal. And then you have ketones, which are the second type of carbonyl compounds. In ketones you will have C double bond O, but then this occurs in the middle of the carbon compound, so therefore the carbon is attached to two other carbons. An example for this is acetone, which is CH3 C double bond O CH3. Now there is another kind of compound known as carboxylic acid. So in carboxylic acid, instead of hydrogen, an OH group is added to the carbon that undergoes double bond with oxygen. So COOH as the functional group gives you a carboxylic acid. A great example of that is acetic acid, which is vinegar. And then finally you have esters. Now what are esters? Esters are sweet smelling compounds which contain the COO group. So essentially you have a carbon which is bonded to an R group, that's a carbon compound, and then it undergoes double bond with oxygen, and then it also undergoes a single bond with oxygen, which in order to satisfy its valency undergoes a covalent bond with another carbon group. So an example for an ester would be CH3 C double bond O O CH3. So this is methyl ethanoate. So this is an example for an ester. Now finally we have saponification and esterification reactions. So what exactly is esterification and saponification? Esterification is basically formation of an ester. Now esters are formed when you react a carboxylic acid with an alcohol. So when alcohols react with carboxylic acids, you form esters, and this reaction is known as an esterification reaction. Now, what is saponification? Saponification is the exact opposite of esterification. So esters plus base gives you acid plus alcohol. Now you either get an acid or you get a salt of acid, which is what we call as soap. So in saponifications, esters reacting with an inorganic base is getting cleaved, it's getting split into an alcohol and a salt of carboxylic acid or a carboxylic acid. If you get a salt of a higher order carboxylic acid, you call that a soap. And that's why you get soaps and detergents when saponification takes place. So this is the general overview of the chapter Carbon and its Compounds. Mind maps are very key in undergoing last-minute revisions for exams. However, if you really want to have a more comprehensive idea, you can always refer to a flow chart. So in a flow chart, the concepts are arranged in a chart which flows, which gives you a flow of ideas of what each topic is supposed to give you. So in carbon and its compounds, the most important part of carbon and its compounds is the classification of hydrocarbons, which contain only carbon and hydrogen atoms. So as we have said earlier, hydrocarbons are classified into aliphatic and cyclic. Aliphatic and cyclic compounds. So aliphatic hydrocarbons are saturated, which means they have only single bonds, or unsaturated, which have multiple bonds. And among multiple bonds, you have double bonds in alkenes, triple bonds in alkynes, and in saturated hydrocarbons, you have a single bond among all atoms in alkanes. Now, these hydrocarbons are open, which means they can be straight chain or having a branch. However, they're not closed. If you have a closed carbon chain, then it's formed then it's called a cyclic hydrocarbon. There are two types, allocyclic and aromatic. Allocyclic is when you have only one type of bond for the entire chain, and aromatic contains two different types of bonds which are alternating. So therefore, benzene is a good example for an aromatic hydrocarbon. Cyclohexane is a good example for an allocyclic hydrocarbon. So we hope you found this episode interesting. For more such mind maps and flowcharts, don't forget to visit the link for our playlist on grade 10 chapters of CBSE. It's present in the link in the description. It's present in the description down below, so don't forget to check that out. Also, if you want to access more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.